In this video, we're covering the last section of our semester. That is section 9.2 on the dot product. There's actually a lot of questions, or a lot of types of questions that could potentially go into the section related to dot product. But our homework only asks two types of questions, really. And so we're just going to cover those two in this video. And you don't need to learn the rest of the stuff in that section. So just concentrate on these two types of examples. These are the only two types of examples that are on the homework. And that'll be it for this semester. So for the first question, we're going to let u equal 3, 2 and v equal 2, 7. And the first thing is just find the dot product of u and v. Well, what is the dot product? The dot product is if we have a vector a1, a2, and we dot this with b1, b2, the dot product is just a1 times b1 plus a2 times b2. And that's, of course, in your book. So let's apply that to these vectors u dot v. So that's 3, 2 dotted with 2, 7. This is 3 times 2, 3 times this 2, plus 2 times 7. And that is 6 plus 14, or 20. And that's it. That's how easy it is to calculate the dot product. It might seem weird that we've defined the dot product in this way, but this actually has a lot of uses, both in physical interpretations and other calculations. One of our interpretations is we have this formula for finding the angle between two vectors, u and v. And the angle between two vectors is cosine of theta is equal to u dotted with v all over the magnitude of u times the magnitude of v. So this gives us a nice way, a nice interpretation of finding the angle between two vectors by using this thing called the dot product that we just did in the first example. So to calculate this, we need to calculate u and u dot v. Well, we've already done that. That was 20 in that first problem. But we also need to calculate the magnitude of u and the magnitude of v. So we'll do that over here to the side. The magnitude of u is equal to the square root of 3 squared plus 2 squared. 3 squared is 9, 2 squared is 4, so we get 9 plus 4 is 13, so it's the square root of 13. The magnitude of v is equal to the square root of, so v was 2, 7, so this is 2 squared plus 7 squared. 7 squared is 49, 2 squared is 4, so this is square root of 53. So this is, the magnitude of u was the square root of 13. We multiply this by the square root of 53. This is 20 over the square root of 13 times 53 is 689. So we get cosine of theta is 20 over the square root of 689. This tells us then that we take cosine inverse of 20 over the square root of 689, and that would equal our angle theta. And so that's how we calculate the angle theta, where that is the angle between two vectors. So the dot product gives us a really nice and easy way to calculate the angle between two vectors. All right, we have one more type of question, very much related to part B of number 1, though. And that is to determine if the two vectors are perpendicular. Well, looking at this formula up here, cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. If two vectors are perpendicular, that means the angle between them is 90 degrees. So cosine of 90 degrees is 0, so that means this right-hand side would have to be 0 if these two vectors are perpendicular. Well, if the right-hand side is 0, that means the numerator is 0 and the denominator is not. So these vectors can't be 0 themselves, and u dot v needs to be 0. So really we get that if two vectors are perpendicular, then their dot product is 0. And in fact, also, if their dot product is 0, then we get 0 over, and as long as u and v aren't 0 themselves, then we get 0 over a non-zero value, so this whole thing on the right-hand side is 0. If that whole thing on the right side is 0, that means cosine of some angle is 0. Well, the two angles are pi over 2 and 3 pi over 2, or in other words, 90 and 270 degrees. Well, both of those are right angles to the angle 0. So if u dot v is 0, then theta is a right angle, i.e. the two vectors are perpendicular. So again, what all that tells us is that if two vectors are perpendicular, then their dot product is 0. And if the dot product is 0, then the two vectors are perpendicular. So to calculate if two vectors are perpendicular or not, we just need to calculate their dot product. And the dot product of 1, 2 and 3, 6 is 1 times 3 plus 2 times 6, which is 3 plus 12, which is 15. Is that 0? No, so these are not perpendicular. All right, so let's check for the vectors 1, 2 and 4, negative 2. Are these two vectors perpendicular? Well, u dot v is 1, 2 dotted with 4, negative 2. So this is 1, this is 1 times 4 plus 2 times negative 2. Well, that is 4 minus 4, which is 0. Is that 0? Yes, it is. So these two vectors are perpendicular. And that's it. That's it for these questions on section 9.2. Congratulations on the end of the semester.